Good evening. So, welcome back to the lecture series in control systems. This is Dr. R. Karthik, and today in our series we are going to discuss the time response of the system. So, what is this time response? So, now if the output of a control system for an input, if it varies with respect to time, then it is called as the time response of the control system. Now, normally the time response just consists of two parts. One is nothing but the transient part, the other one is your steady state part. So the transient part, the other one is your steady state part. So now this is the response what we are talking about. The initial part, now where we have the changes, now you call it as the transient state as the time increases, and when it takes a constant value, okay, after initial rise, now you call it as the steady state. So basically time response, it is nothing but the output as a function of a time in a control system. The output as a function of a time. So we know what is the output. Now we know the transfer function, that is C of S by R of S. C of S by R of S is equal to, now it is G of S divided by 1 plus G of S into H of S. G of S into H of S. Now this it is our closed loop transfer function. Now here C of S is the output. So here now we get C of S is equal to, now we just cross multiply R of S. So R of S goes into the other side. And now this entire one, G of S divided by 1 plus G of S into H of S, I'll just consider it to be M of S. Now we require to find the response as a function of time. So I'm going to get a C of t. So which means now we have to convert the S domain into the t domain, where I get the Laplace transform of R of S into M of S. So this is my time response. Now where you can see it is a function of time. So before getting into the actual time response of a system, now we need to understand, now you can see from this equation, now we require the information about the input to the system. R of S is nothing but the input to the system. So the information about the input should be known in order to find the response of the system. So basically for any system, the input will not be known ahead of time. It is not possible for us to predict the input, but the input, it has certain characteristics for any system. It can be like, it resembles a sudden shock. It can be a sudden change. It can be a velocity type input, that is which varies linearly. Now all these are certain characteristics of an input which actually occur for any system. But our problem is these systems or these inputs may not be known ahead of their occurrence. So in that case, now in order to model a control system, now what we do is we generate these signals which resemble the characteristics in the laboratories. So these signals are called as the test signals, which are used to model a system. So there are various test signals. Now we'll be just discussing one by one. So the first one is nothing but the step signal. So the first one is the step signal, one of the standard test signals. So here you can see the test signal. It is nothing but, I just refer to the graph, the signal which rises to the value 1 at time t is equal to 0, after which it remains constant. Such a signal, you call it as a step signal, and it is mathematically expressed as, now you can see R of t is equal to A into U of t, where this U of t, it is equal to 1 for time t greater than or equal to 0. So it is 1 only when time t is greater than 0, but for less than 0, this value is 0. So the input is valid only for time t greater than 0, and it is equal to 0 when time t is less than 0. So R of t is equal to A into U of t is called as the step signal. And now we have a special case in which this A, if it is equal to 1, so as this case, then you call this as a unit step signal. You call it as a unit step signal. So unit step signal or a step signal, a signal which has a value that is, it rises to 1 at time t is equal to 0. So this is the first standard test signals which can be generated in the laboratory is called as the step signal. And the second one, now we call it as the ramp signal. So ramp signal, you can just refer to this graph. Now it is a signal which starts at value 0 and it increases linearly with respect to time. So as time t increases, the input signal also increases. Such a signal, you call it as the ramp signal. And you can see it is expressed as r of t is equal to a into t. And this signal is valid only for time t greater than 0. So if it is less than 0, we don't have any value. So such a signal, now this represents the velocity input to the system. So wherein a signal whose value starts at 0 and increases linearly with time. And again here we have a special case, that is when a is equal to 1, you call this as a unit ramp signal. When a is equal to 1, you call it as a unit ramp signal. Now the third signal, now we call it as a parabolic signal. So if a signal, you can just refer to this graph. Now in this signal, the instantaneous value, it varies as a square of time. This is very important. It varies as a square of time. And it starts at time t is equal to 0. So this signal also starts at time t is equal to 0 and it varies as a square of time. And mathematically it is given by r of t is equal to a into t squared by 2. And this signal is valid only when time t is greater than or equal to 0. If it is less than 0, then your input signal is equal to 0. Once again, a special case. Now when a is equal to 1, now you call this as a unit parabolic signal. When a is equal to 1, you call it as a unit parabolic signal. And then we have the next one, we call it as the impulse. This is the fourth one. It is called as the impulse signal. So a unit impulse signal is defined as the signal which has a 0 value everywhere. So everywhere the signal has 0 value except at time t is equal to 0. Now you can see only at time t is equal to 0, now its magnitude is infinite, but rest everywhere other than 0, the value is equal to, that is the magnitude is equal to 0. Such a signal, you call it as the impulse signal. That is, it is represented by phi of t is equal to 0, that is for t not equal to 0. Because as per our definition, impulse signal, it has only when time t is equal to 0. So such a signal is called as the impulse signal or a unit impulse signal. So far, and apart from this, now we have one more signal which you call it as the sinusoidal signal. Sinusoidal signal, now which is nothing but generation of sine wave. So these are the 5 standard test signals, and all these signals can easily be generated in the laboratories. So which are used in order to test a system, because the input signals cannot be known ahead of their occurrence. So therefore these test signals are used for modeling of a control system. So that's it for today. Thank you very much.